And I'm having problems with my iPad too. Yeesh, it's falling apart. All right. So Chemistry 3101, we finished chapter 8, which is the alkenes chapter. We finished the content of it. So chapter 8, which deals with the chemistry of alkenes. And today I wanted to spend some time looking at a few problems. And we're going to start with question 8.57. And in the textbook, they ask us to take this primary alcohol, or this compound here. This is called 1-propanol. And then they ask us to make 2-propanol. And they actually ask us the reverse reaction as well. But I think we'll just start out with this one. And so if we think about, how we might do a reaction like this, there's actually more than one way that you could do this. But there's one way that would be the most effective way that I think. And what I want to do with you is think about a retrosynthesis, because if we could make a propylene molecule, or propene, whatever you want to call it, all we would have to do is a Markovnikov addition of water, so just aqueous acid, and that would give us the desired compound. So that would give us this compound here, right? The rich would get richer, and we'd get the hydroxyl in the middle carbon. So my question to you is, how would we get from this primary alcohol to this alkene? Well, there's a couple of ways you could do it. You could make a tosylate, and then you could do, you could do an elimination reaction that way. But the easiest way to go from this alcohol to this alkene that I have in blue is to treat it with concentrated sulfuric acid. So step one, actually, let's write the whole thing out. Step one is going to be to treat it with concentrated sulfuric acid and to heat it up. Right, and that's going to drive off water. Sometimes we put minus H2O just to kind of show the reader what small molecule we're losing, and that is going to give us the desired alkene like this. And then all we have to do is a Markovnikov addition of water across that double bond, and that's going to give us the desired product. All right, so that's the first part of that question. But the second part is the reverse. So I'm going to write this out in blue. If we wanted to take that alcohol, and if we wanted to convert it into this alcohol, so if we want to take, it would be 2-propanol to 1-propanol. Anyhow, the names aren't important because we haven't covered alcohol nomenclature yet. But anyhow, so what would we want to do here if we think in terms of retrosynthesis? If we think of making propylene again, so my question to you, Eric, is if I'm just using it. If we wanted to go from here to here, if we wanted to make this alcohol, would this be a Markovnikov or an anti-Markovnikov addition of water? Could anybody answer that? Yeah, exactly. It's going to be anti, right? Exactly. It's going to be anti. And so in our first step, again, we're just going to treat this with sulfuric acid. So we'll put here concentrated H2SO4, heat, and of course that's going to cause the loss of water. So that's going to give us propene. And then if we want to do an anti-Markovnikov addition of water, of course that's a two-step reaction. The first step is borane and THF. And the second step is going to be to treat it with hydrogen peroxide and sodium hydroxide. All right, so what you see here is that you can go forward or backward. Now you have the prowess, to be able to do either one of those transformations. So yay us, yay students. All right, so let's take a look at B. Just give me a chance to write it down here. So this is 8.57, 8.57, and this is question B. And in this one, we're doing something similar where they want us to take this tertiary alkyl halide first, and then we're going to make a secondary alkyl halide. So let me just scribble that down here. All right, so we want to go from this tertiary to this secondary alkyl halide. And we've got to find a way to do this. So if we think about a retrosynthesis, in terms of a retrosynthesis, we would want to make this compound, right? We'd want to make this compound from this alkene. Oops, I have an extra methyl group there. All right. So if I had this alkene in blue, not my best artwork, let me fix that up a little bit. Like that. If we had this alkene in blue and we wanted to convert it to the product, would that be a Markovnikov or an anti-Markovnikov addition of HBr? If I want to go from here, from the blue compound to the final product. Could anybody answer that? If I wanted to go from that alkene to that secondary alkyl halide, would that be Markovnikov or anti-Markovnikov? Well, that would be an anti-Markovnikov, right? Thanks, Kiana. Perfect. Yeah, thanks a million. And so, right, Kiana, now we've shortened the problem greatly. Now the problem is, well, how do we get from here to here, right? And well, we see that we have two types of beta protons. So if we just zoom in on this compound, this is our alpha carbon. This is a beta carbon, and then this is also a beta carbon. So we have the beta protons in blue, and I'll just write this one in black here. So we can pull off either one of those, but we need to pull off the one, maybe I should have color-coded that, the reverse, right? We want to pull off the one in black in order to get this compound. So maybe I'll change the color to green. There we go. So we want to make this compound, and so we would pull off the proton in green. And so my question to you is, do we need a hindered base or an unhindered base to pull off that proton in black? Could anybody answer that? Would I use a hindered base or an unhindered base to pull off the proton in black? I'd use an unhindered base, right? Because that one is on a secondary carbon, right? So it's attached to 2 carbons. So if I look at this carbon, it's attached to 2 carbons. So I'd need an unhindered base. Whereas if I tried to pull off the blue proton, that carbon is only attached to, oh, I got this extra carbon here still. That's only attached to 1 carbon. So you would need an unhindered base in this case. And so we would use something like sodium ethoxide or sodium methoxide, and that will give us the Zaitsev product. And so then if we want to do an anti-Markovnikov addition, we use HBr and inorganic peroxides, and there you have it, all done. So now what we want to do is the reverse. If we want to take the starting material, so here's our starting material, and if we want to make this compound, so we want to make the tertiary alkyl halide, so this guy here, right? We could still make it from that same alkene. We could still do the same retrosynthesis, right? We can make it from this guy, but now we would want to do a Markovnikov addition of HBr across this alkene. And so we know how to make that alkene, the alkene that I have in red. If we have the bromine in this position, we have 2 types of beta protons. We have these beta protons, and then we have these beta, or that beta proton and these beta protons. So if I want to pull off the proton in red, I'm going to use an unhindered base, like sodium methoxide again. So I'll just put in here sodium methoxide this time, just to mix it up a little bit, and that's going to give us the Zaitsev alkene. And then I just need to do a Markovnikov addition of HBr, and we're done, just like that. So now we see that we can go frontwards or backwards in this reaction and get the products either way. Okay, so the next question does the same thing. So this again is question 8.57. And this is part C. So we have some stereochemistry we have to draw in here carefully. So let me make sure I get it right. They have a chlorine coming up like this, a methyl group going down. Then they have a methyl group coming up like this. And then they have the cis 1,2-dimethyl cyclohexane. So we have this going up and this going up. All right, so if I want to affect this transformation here, I want to think in terms of retrosynthesis again. You know, what kind of starting material would I want to make this compound? Well, you can see that we have a hydrogen going down here and another hydrogen going down here. And we know that hydrogenation affects a synaddition of hydrogen. And so if we could make this compound, so this would be 1,2-dimethyl cyclohexene, then all we would have to do is a hydrogenation and the reaction would be finished. So my question to you is, if we look at the starting material, this is our alpha carbon, right? We've got 2 types, we've got 3 types of beta protons here, don't we? We've got this beta proton here in green, we've got this beta proton in blue, and then we have this beta proton in red. But if I want to pull off the one that's going to give me the Zaitsev alkene, I'm going to want to use a hindered base, or sorry, an unhindered base, because an unhindered base is going to pull off the most hindered proton to give me the most substituted alkene, which is the most stable of all the alkenes. And so if I use an unhindered base, I could choose sodium methoxide or sodium methoxide. I'll just choose sodium methoxide. So sodium methoxide, and that's going to give me the Zaitsev alkene. And then all I have to do is treat it with hydrogen, palladium, platinum, or nickel. So I'll just choose palladium today. And there we go. We get, and remember, this is syn addition. And so we end up with that cis 1,2-dimethyl cyclohexane. Now we want to do the reverse. So if we take the cis 1,2-dimethyl cyclohexane, so that's this compound, I'll draw it in here carefully. And if we want to make the chloro compound, so we've got the chlorine coming up, got this guy going down, and this methyl group coming up like this. All right, so if I want to make this compound from the 1,2-dimethyl, does anybody have a strategy for this one? Actually, sorry, this one they don't ask us to do the reverse. Let me check the question. Oh, they only ask us to do it one way. Well, in this one, we don't actually know a way to do that. Sorry, I'm getting ahead of myself. This is something actually that we would cover. We'd be able to do this in chapter 10. Okay, so my mistake. They only wanted us to do it in the forward direction. Let's do the last one. So this is 8.57D. And in this one, we're taking this alcohol. This is called cyclohexanol. And then we want to make a cis-diol from it. And so this gets you to practice your dihydroxylation reactions. Make sure you're confident in those. And of course, we would make the diol. The only way we know how to do that is from an alkene. So we need to have cyclohexene. And the easiest way to make cyclohexene from cyclohexanol is to use my favorite reaction. I just heat it up in sulfuric acid, and there's only one possible. There's no Zaitsev, there's no Hoffman here. There's only one alkene that you can make. We'll just put concentrated sulfuric acid and heat, and that's going to give us the cyclohexene. Could anybody give me a set of conditions to do the syn dihydroxylation? Even if you just give me a reagent or part of a reagent, that's good enough. I can fill in the blanks. I want to do a syn dihydroxylation. Yeah, thanks, Kiana. Exactly, osmium tetroxide. So we'll put catalytic amount of osmium tetroxide because osmium is just so toxic. And then we'll put NMO as our co-oxidant. Remember, NMO stands for N-methylmorpholine N-oxide. I'm never going to ask you to draw the structure of that compound. You can memorize it if you want to, but you don't have to do that. Okay, so we got that one done. The other question I wanted to look at was 8.69. So let's go over to 8.69. Just give me a second to write it down, and then we'll kind of tackle it as a group. So 8.69, we have 1-methyl cyclohexene, this guy, and they ask us to do all kinds of transformations. They ask us to make methyl cyclohexane. Then they ask us to make a halohydrin. So they ask us to make this halohydrin. So we have a hydroxyl here. Just bear with me. I'll try to get these written down quickly. And of course, that would give you the enantiomer as well. Then they ask us to make this cool compound. It is an aldehyde. My mistake. So 1, 2. There we go. That's better. So they ask us to make this compound that has a ketone and an aldehyde in it. And finally, we're asked to make this alcohol. So let's scribble that down, which looks something like this, plus the enantiomer. There we go. All right, so this is 8.69. 8.69. So let's see if you guys can help me find some reagents to do these transformations. So for the first one, so where are we? So for the first one, I'll put a red question mark over that. If we want to go from an alkene to an alkane, anybody have a reagent we could use for that? I'll take anything. Not anything, but here you go. Thanks, Eric. Yeah, hydrogenation, absolutely. I'll put here hydrogen gas. Let's choose nickel to be cheeky. That doesn't get a lot of love. What about the next one? If we want to do a halohydrin, we have a bromine and we have a hydroxyl. You can see that it's anti-addition, right? And the hydroxyl ended up going on the more substituted carbon. So what would my conditions for halohydrin formation be? So I'm going to write that down here while here. So this is a halohydrin. So this one would be bromine, right? Bromine to make the bromonium ion, and then we have water as our solvent. All right. And I told you this is a reaction that you should know the mechanism of, so I'll put a little star by it. Okay, the next one is an ozonolysis reaction. We went over this last class and talked about the skill builder, where it shows you how to cleave this bond, right? So what you would do is you would take that cycloalkene and you could draw it in a ridiculous way if you wanted, like this, and show the double bond. And then what you do is you take your eraser and you would erase this, right? And then you put an oxygen here and an oxygen here, and that's this compound, is what you're getting. All right. Does anybody remember the conditions for this reaction? Even one of the reagents? Yeah, thanks, Kiana. Absolutely. Yeah. Ozone would be the first step. And the second step is dimethyl sulfide. We abbreviate that as DMS. That's the acronym that we use for that. You can also use zinc and water for the second step, but the textbook, I don't think they use that much in the solutions manual or anything. All right, in the last one, so if I put a red question mark over this, is this a Markovnikov addition of water or an anti-Markovnikov addition of water? Just mark or anti-mark? It's anti. Thanks, everybody. Great. All right, and we went over these conditions this morning. So first step is borine and THF. And the last step is to use hydrogen peroxide and sodium hydroxide. And remember, this is syn addition. So syn addition. All right. There we go. And remember that the hydrogenation is also syn addition. It's not really relevant here because you don't form any stereocenters. And then, of course, the halohydrin formation, remember that's anti-addition. Anti-addition. All right, so that covers those problems. Let's see. So we finished those two problems.